Welcome back, guys and gals, for another fun-filled, action-packed, non-flipped Algebra 2 classroom video. Today, we're going to be doing a streamlined learning experience, and we're going to be learning about compositions and inverses. The objective here is that we're going to be able to use compositions of functions to determine if those functions are inverses. But first, let's start off with a little bell ringer. All right, in order to add and subtract fractions, we need to make sure the denominator is the same. Is 5 the same thing as 10? No, but we can get 5 up to 10 by multiplying this 5 by 2. So multiply by 2, that would give me a 10 on the bottom, right? But if I do the bottom multiply by 2, I need to multiply the top by 2 as well. So 2 times 4, which is 8. Now I got 8 over 10 minus 3 over 10. Now the denominators are the same, so we can just subtract. So we're just going to do 8 minus 3 on the top, that's 5. And the denominator stays the same when you add or subtract. But now we can reduce this further into 1/2, and that is my final answer. Next up, B. Okay, you can't, 3 and 5, they don't turn into each other. So what we can do is find the lowest number that both of them multiply into. So that would be 15. So watch this. I'm going to multiply 3 by 5 and the top by 5 as well. That gives me 15 on the bottom. And what's 5 times 2? That's 10. Now I can get this 5 over here to 15 by multiplying by 3 and multiply this by 3 as well. So that's going to be 9 over 15, and it's a plus. So now we're just going to add straight across. 10 plus 9 is 19. And the denominator stays the same when you're adding and subtracting fractions. So 19 over 15. And C, we're going to use the same strategy. We're going to find the least common multiple. That's going to be 14. So how do I get 2 to 14 with multiplication? I'm going to multiply by 7. And I'm going to multiply the top by 7. So what's 7 times 1? That's 7. And then 7 times 2 is 14. So my first term has become 7 or 14. Now for the second term, how am I going to get the 7 to a 14? I'll multiply by 2. And over here, I'm going to multiply the top by 2 as well. So it's going to be minus, what's 1 times 2? That's 2. And 7 times 2 is 14. So now we've got the same denominators. So let's subtract straight across. 7 minus 2 is 5. And then on the bottom, we've got 14. And that is the final answer. All right, now over here on D, we've got multiplication. Multiplication, you can just multiply straight across. So what's 3 times 1? That's 3. What's 5 times 5? That's 25. That's your final answer. E, same thing. Wait a second, 7, that doesn't look like a fraction, but we can change it into a fraction by putting it over a 1. And then now let's just multiply straight across. 7 times 1 is 7, and 1 times 2 is 2. So 7 over 2 is my final answer. On F, the first thing we can do here is cross reduce. Notice on top we've got a 4, on bottom we've got an 8. Both of these numbers can be divided by 4. So if I divided both these numbers by 4, then 4 would become a 1, and 8 would become a 2. And now let's multiply these numbers straight across. It's going to be 7 over, what's 2 times 5? 10. And there it is. Makes it a lot easier when you cross reduce. All right, let's get on to the main topic here. So remember we did compositions. Well, let's just practice these two compositions real quick. Let's do these. Given that f of x equals 2x plus 3 and g of x equals 1 over 2x minus 3/2, find f of g of x. So let's do A together real quick. So let's rewrite this into a way I know what it is. Equals, this is the same thing as saying f of g of x, like this. Now what is g of x? We can see it's right here. Let's replace that on the inside. So f of 1/2 x minus 3 over 2. Okay, and now we can see that our f function is right here, 2x plus 3. So we're going to use this right here in place of the x. So watch this. Equals equals 2 times, wait a second, 2 times, and I'm going to color code this. Watch this. 1 over 2x minus 3 halves. And the color code 2 times 1 over 2x minus 3 halves. And then what do we have on the end right here? We've got a plus 3. All right, so now let's solve this out. We're going to distribute the 2 to both of these numbers. 2 times 1/2, that just cancels the 2 on the bottom right there, so it just becomes x. And same thing with the second part. It cancels the 2 on the bottom. That just becomes minus 3. And then we can see at the end we've got the plus 3, so let's not forget this. So plus 3. So what is x? Let's combine the like terms. We've got x. And then negative 3 plus 3, that's just 0. So my answer here is x. Oh my goodness. All right, on to B right here. We've got g of f of x. What is f of x? Let's replace it with what we found right here. It's 2x plus 3. And then g is still right here. Boom. And now let's replace, look at my g function, 1 over 2x minus 3 over 2. So we're going to put 1 over 2, parentheses, 2x plus 3, close parentheses, and then what is it? Minus 3 halves. This is getting a little jumbled. All right, let's distribute first. 1/2 times 2, 1/2 times 3. What's 1/2 times 2? That's actually just going to be x. So I'm going to write it over here. X. And that's what's 1 over 2 times 3. That's just going to be 3 halves. So plus 3 halves. And then we can't forget the minus 3 halves at the end. So minus 3 halves. And then once again, wait a second. These two cancel out. So my answer here is x. Whoa! Wait a second. Look at these two compositions. F of g of x, my answer was x. G of f of x, my answer was x. Oh my goodness, why do you think that is? This is the topic of today, guys. When you do a composition and your answer both ways equals x, that means that those two functions are inverses of each other. Oh my goodness, that's crazy. And as for proof, watch this. Remember, inverses, we just take one function. So I'm going to do f of x, okay? Watch this. Inverse, remember, we're going to take that function and we're going to set it into y. I'm going to find the inverse of f of x. So f of x, I'm going to write y equals 2x plus 3. And then what do, guys? We switch the x and the y, remember? X equals 2y plus 3. And now I'm going to solve for y. So minus 3, that's going to be x minus 3 equals 2y. And then I just need to divide by 2 to get the y by itself. Divide by 2, divide by 2, divide by 2. And we can see that, oh my goodness, wait a second. Y equals x over 2, which is the same thing as 1/2 x, minus 3 over 2. Wow, I found the inverse function of f of x right here. And it gave me this exact g of x. It's true. When you do the compositions of each other and it equals x both ways, they're the inverse of each other. That's crazy. So let's use this idea in some examples. Use the composition of functions to determine whether the functions f of x equals 1/2 x minus 3 and g of x equals 2x plus 6 are inverse functions. Let's check it out then. So we need to go both ways on the composition. So on one of them, I'll write f of g of x. And for the other one, I'm going to write g. Oh, wrong color. I'm going to write g of f of x. And we're going to solve both of these compositions. And if they're inverses, both of the answers should be x. That's right. Let's see if it actually works. So here we go. Oh, open my disk for some reason. All right, here we go. So this first one, let's replace g of x with this 2x plus 6. So 2x plus 6. And we've got the f over here. F, boom, equals. Now we're going to use this function right here, but replace the x that we see in there with 2x plus 6. It's going to be 1 over 2 times 2x plus 6, close parentheses, minus 3. So now let's distribute. 1/2 times 2, 1/2 times 6. What is 1/2 times 2x? That's just going to be x. And what's 1/2? Whoa, what's 1/2 times 6? That's just going to be 3, so plus 3. And we got minus 3 at the end. The plus 3, the minus 3 cancels each other out. Boom, my answer is x. Okay, one way, check mark. Good job, boys and girls. Now let's make sure the other way works as well. So let's replace f of x. What's f of x? It is 1 over 2, x minus 3. And we've still got the g. All right, next then, let's replace the x in the g function with the 1 over 2x minus 3. So 2 times 1 over 2x minus 3 plus 6. So now let's distribute. Boom and boom. What is 2 times 1/2 x? 2 times 1/2 x is just going to be x, okay? What's 2 times negative 3? That is negative 6. And then we got the plus 6 at the end right there. And then once again, we see, oh my goodness, the negative 6 and the positive 6 cancel out. My answer is x. Wow, so both of these compositions gave me x, which means they are inverses. Inverses. Yeah. All right, so moving on. I want you guys to try this next one. B on your own. Looking at C, check out this note. If one composition doesn't equal x, then you can stop. They are not inverses. So take a look at these two. F of x is 3x plus 12, or f of x equals 3 over 4x plus 12, and g of x equals 4 over 3x minus 12. Wow. Okay, so let's determine if these two functions are indeed inverses. So let's just go ahead and do f of g of x. All right, so what is g of x? G of x is 4 over 3x, 4 over 3x minus 12, okay. Still got the f now, and now let's replace in the f function. So we've got 3 over 4 times 4 over 3x minus 12, close parentheses, and then we've got the plus 12 at the end, plus 12. All right, here we go. Let's distribute first of all. Boom, here we go, boom and boom. 3 over 4 times 4 over 3. Let me just do this on the side so we can see. 3 over 4 times 4 over 3. We multiply straight across. What's 3 times 4? 12. What's 4 times 3? 12. This equals 1. I can't write over there. So then this just means we got x over here, right? Now 3 over 4 times negative 12. Let me do this on the side as well. 3 over 4 times negative 12. And I want to make it a fraction, so over 1. So I'm going to multiply straight across. 3 times negative 12 is negative 36. And then 4 times 1 is 4. Reduce this. Negative 36 over 4 is negative 9. So it's going to be x minus 9. All right. And then don't forget about the plus 12 at the end. Plus 12. So then what does this equal? X negative 9 plus 12 is plus 3. Wait a second. I just went through this composition and I didn't get x. My answer was x plus 3, coach. What does that mean? It means they are not inverses. These are not inverses. I only needed to solve one composition. I didn't get x. That means no, not inverses. I can stop. I don't need to do more work. I'm saving you guys trouble. On to D. Find the inverse of f of x equals x squared minus 3. This one just has to find the inverse, so this is a problem like we did yesterday. What do we do to set up our equation? We're going to write the exact same thing first, but with a y in place of f of x. So y equals x squared minus 3. Notice everything's the exact same except I wrote a y. Next, to start the inverse process, we're going to switch the x and the y. So x equals y squared minus 3. And now let's solve for y squared. So we're going to add 3 to both sides. Boom, boom. That's x plus 3 equals y squared. And then we're going to take the square root of both sides to cancel out the squared. Boom. And it's going to be, that's gone. And remember, when you take the square root, guys, when you take the square root, your answer is not only going to be positive, but it is going to be negative as well. So it's going to be plus or minus square root of x plus 3. And that equals y. But that's not the end of it, remember, because this is not full points. If I wanted to get full points, what would I need to do? I need to not write y, I need to write f, -1 up here, of x equals, and then my answer, plus minus square root of x plus 3. There you go. That will be my final answer. That's the inverse of f of x. On to the very last question. Let's read this together. Maria finds that f of g of x equals x. All right, cool. She therefore concludes that f and g are inverses of each other. Is this conclusion correct? She did one composition and she assumed that they're inverses. Is that true or false? It is false because Maria's being lazy and she's just trying to do half the problem. You got to do it both ways. She found f of g of x. She still needs to test g of f of x. No, Maria. We can't be lazy here. So it is false, not correct. The end. That's the end of these notes, guys. See you in the next one. Peace.